then each student to have to do one member design and one collection design. According to your lab sheet, so when you choose a member A, then you need to design the front page or the moon. Okay. So anyway, when you design the page, you need to design the member A. When you design the column, okay, I will show you later. Okay. Two students to form a group. Two students and form a group and submit one report by two students. And then each student should design a member and also a connection. For example, you want to design a bid, then you need to choose the member A. Okay. When you want to design a column, you can design the D or F. Okay, up to you. Alright. Because the column A has the secondary page, so it has a lateral restraint. So you need to design the visual collection. And then you also need to design the mobile collection or the column page. Up to you. You should compromise with your student. Okay. So this is the mobile collection that you design for this one, and this is the for PN column page. Okay. This is your assignment. This is your assignment. You know what to do. And in this computer lab, I just demonstrate how to set up the modeling, and hopefully you can complete the modeling by today, or you need to revise some detail. So, yeah, and then this is also same for the student from the last session. They did all the modeling, but need to revise some session or some modeling only. Okay, so I hope you can do the same way. And just speed up. Save your time for prepare for your final exam or the midterm test. And then also, I just want to say, I like to do revision for you at the week you have the midterm test. Okay. I also announced it through my tutorial class, right? Because I want to tell you how to prepare your midterm test and also the final exam. I will tell you how to prepare the question, what you should focus on your answer, and how to give mark, so such that you can focus what kind of the procedure is essential for you. Okay, but I remind you, because this is my personal contribution, I won't circulate online. So for the student online, I will put all my solution and my own marking scheme on the whiteboard only. So the student online, they can get it from the webcam, but not here. So I just recommend you can attend my revision class in person at the school. Okay? Okay, I just try to help you how to prepare for your final exam. According to my experience last year, many students can get a higher grade. Okay, that's not too difficult when you want to get a higher grade, but you need to do more. For example, you need to do the written example first. Build up your confidence. When you have enough confidence, you can try the past exam. When you do more, then it's easy. Easy for the midterm test and then easy for the final exam. Field design is very easy, straightforward. All the procedures, you should follow all the procedures, then it's done. Okay? Now, today, I want to go through how to set up the modeling. And then, this is your task. You need to design. So this also help you to for final exam, design configuration. Okay. Now, this is the framing, and then this is the image. I have the frame, I have a steel frame. And then we use the high-strength scale. We use the high-strength scale. And for the beam A, then this is a electrical administration, and then critical to the beam buffer. You need to check that. So when you want to design the beam, you need to choose the A. When you want to do the column, then you can choose the FE or F. Okay. And then the concrete step grade is the 40. It's quite useful on 30, 40, 50. And even the high swing concrete 60, more than 60. It's also okay. But you don't need to design for the concrete step, and there's no any composite action. Okay. the concrete step is model in the computer model. I will tell you later. Okay, it's just because the how to go through the model. We don't need to model the concrete step anyway. And first, and then on the first and then ground floor, then the loading is here, and then on the roof is like here. And this is the low factor table, the table of low factor. Even though we just have the three low combination, but however, in this project, you just need to do the vertical low case only. This is the lateral low case, You just need to do the 1.4 and 1.6. But in your actual design project, even you just based on this three low case, you can assemble more than the 400, 600. According to my experience, to do the pressure pitch structure, according to this structure, it's easy to assemble the 400 okay. For the sports stadium, then we have the 600 okay. So actually, you can try your partner in this project using based on the 1 okay, 1.4, 1.6. But you can test yourself. You can how many locates you can assemble for this simple structure. I have the experience for the simple structure for this project the last couple of years. I can assemble 14, for example. Okay. So, but anyway, this is based on 1.4, 1.6 enough. But in the real world, there's so many low combinations, even based on this simple table. Okay. Now, the rear load and then the lateral load is not included in this project, so this is so you need to consider the vertical load case only. And this is the requirement for the students to what you should do. Okay, you should do the A, when you do the B, do the A, when you do the column, E or F, up to you. Okay, and this is the structure. Okay. The important thing of this structure is I have a staircase here. So I have the opening. If I have the opening, then I should have the secondary beam. Secondary beam supports that. Okay. So I just write this beam has a lateral restraint from the secondary beam. Same for this one. Okay. And I also have the bracing. It's a reminder. The bracing cannot be applied or installed in this phase. You can only apply at the end. Because I have this the question from student. If I have the staircase here, it means that I have the people may come from this way to this side. If I have the bracing in the middle, then this is not possible. This is not the view of this unit. This is not the view. Okay? And then yeah. All the egg connection of the braces should be inside and pin. And then also the column base. For the all steel structure, the column base most likely will be inside and pin. This is very common. If you design at the moment job, you will find the column base is very complicated. You need to apply the stiffener to transfer the moment. This is not common. So this model is also designed as P. And also, the secondary plate connected to the main plate should be designed at the P end. Because you don't have any so many space for you to install the secondary plate to main plate, for example. This is the main plate. Okay? Top flange and the secondary and the bottom flange. And I will have the secondary beam. If this secondary beam to take moment, then I need to provide, this is the typical moment job. So if I connect the secondary beam to the main beam, that's having enough space for me to put enough bolt to take moment. And also, one bolt on the bolt may not enough. I may have the secondary bolt or second bolt on the bolt to take moment. Okay, so this is not enough. So this is easy when I design at the plane. I will have the plane and then take it, and then this plane will weld to the rack of the main plane. So that's easy. I mean that pin end is easy than the moment job. Okay. So this is the normally for the secondary pin to the main pin connection, they should design a pin. Okay. Anyway, I will tell you how you reflect this end condition in the model. So this is the pin, this is the pin, and then this is the pin. And then I will tell you later. All right? Okay. Done. Go to the any student online, go student online, okay. So I don't record. Because you get the record from the last session. Okay. Okay, I want to help you to get through the modeling, and then hopefully you can finish your modeling by today. Okay. It's really easy according to the skill last session. I'd like you to know, as you want to choose the structural engineering and your future career, modeling, the skill of the computer modeling is very essential. This is a quite daily routine as the structural engineer. Okay. I want to discuss demonstrate how to set up the modeling. It's not only the computer skill, but also I want to tell you more behind the computer model. This is the computer method, or the student method, or finite element method. You heard the I think you heard that finite element method. So most of the computer programs they also based on finite element method. And finite element method make use of the student method. Okay, so. All right. You need to okay. Okay. You want to set up a computer model. When you want to set up a computer model, you need to fulfill 5 requirements. And because you need to fulfill these 5 requirements, this 5 requirements is just because of the computer method, or the finite element, or the student method. Okay. First, the geometry, element and the look. Because the element and the look can help you to define or to set up, establish the student matrix. Have you learned the direct student analysis from the structural analysis? For example. You want to assemble the student matrix. Well, I have the member 1, and then connect it to the member. Maybe element 6. So, the geometry of the structure can tell you, or the connectivity can tell you how to assemble the global student matrix. When I have the global student matrix, I can solve the whole structure. It means that I know how it behaves, I know how it defaults, and what is the load distribution. That is the purpose of the structural engineer. Okay, they are our aim. Okay. Geometry can tell you how to assemble the global student matrix. Okay, so you want to get the model. Most of the structural program they will have the template. They have a number of the options for you to start up. Okay, so you know our structure, the geometry of our structure like that, and can you first? Before you set up a new model, you need to pay attention of your unit. Unit is very essential because you get the loading and get the deflection. It's all based on this, According to the engineer, structural engineer, they would like to use, when you choose a meter, then it should be the kilonewton. Or you can choose millimeter, you can choose newton. Okay? or I like to use the Newton. I like to use a meter and then kilonewton. But however, sometimes you want to export the geometry of the structure from the AutoCAD drawing. AutoCAD drawing, they also based on the millimeter. Okay, then at that time you need to do Newton. But for your newly adapted model, you can base a new meter and kilonewton. Okay. So now, can you tell me which model is quite similar? It's quite similar to our structure. Which one? There's no exactly same model from the template match with our structure. But anyway, which one is close, and then we can revise. Okay. Which one you want to choose? Okay. All right. Now I think this is a space thing. This space thing is close to our structure. Okay. I choose this one. Okay. We had a 3-story. We have 3 story. Each story is 3.5 meters. And then one. Okay. This is 1 bay in transverse direction. And then there's 2 bay. When you define like this, you also when you define like this, then you also define the global axis. I will tell you what is the relationship between global axis and local axis. And local axis can help you to determine the bending axis of your member. And in axis, because there's 1 bay, that is a 7 meter. Yeah. This is axis, and then 1 bay is 7 meter. And then the y and 6 meter. Okay, I get it done. You know, I have in this page I just have 2 stories. In this page I need to remove, erase this fragment. Okay, first let's check. Okay. I want to tell you that in NIDA, you have the 2 ways to select the element. One is from the top hand side, the other is from the bottom hand, upper hand and lower hand. If you choose the upper hand, that every member within the selection box will be selected. Okay. Now, for example, I choose another way around. Okay, if I select the element from the bottom, that the element fully within the selection box will be selected. You can see the difference. This can help you to revise the modeling. I just tell you the scale of your modeling scale. Okay, because I don't need this one, and then I just select it. Right. Everything within the box should be highlighted, and then I just delete, push the delete, and then it's done. First, right? Now I'm also doing the geometry, to assemble the homocylinder meter. Because this is and then also I want to highlight this. The box in your right hand side. This is the property box. Property box can help you to revise the detail property. Okay. For here, I select this base, and then I find that this is just 6 meters. But now you know, this base should be 6 meters. This base should be 8 meters. I need to increase the length of this member by 2. Okay. I can link it. I can for this one. I can move, select all the member, or I can select this way. Doesn't matter, because I want select all the loop in this way. I want to move all this loop in the right direction by 2 meters. Okay. First, if you want to revise your model, normally you should go to the edit and then go to edit, you find move look. According to the global asset, it tell you, I want to move the look in this way, in Y. So this is my input. So I should put the 2. This is in this way, so this is positive 2 in this way. Okay. So I select, I highlight the element, and then I want to move the look in this look. So I will go to the move look. Okay. So I want to move it in the Y direction in this way by 2. So 2. So you can see. And then I check it. Yeah, this is X beta, and this is the 6 meter that we define from the template. Okay. Now the geometry is quite done. Alright? The geometry is quite done. But I had the staircase, I had the secondary gate. So it means you need to insert a look at the midspan of this base. Okay. This is connected. This is one approach you can add an element. So I want to make an element in between this main bay. Okay, I highlight this main bay because I revise the model. I go to edit, and then split member, and I want to split it, divide it by 2. Divide by 2. Okay, I insert a look in the midspan of this element. Now I need to add an element. When you want to add an element, then you should go to the left-hand side. Okay. Here, you don't have any choice. You just define that this is a default session. Doesn't matter. You can change the session later. Okay. Not now. Okay. Here. Do it again. All right. So the geometry is done. Now, there's one thing. Is it the structure you're looking for? You are not sure. Because the bending plane, you have no idea of the bending plane. Is it bending about the major asset? So you have to check. If you want to check the second, I have an easy approach and then a formal approach. The global access. This is a side convention. This is side convention used for all structural analysis or most of the computer program. Right hand side. X, Y, Z, 1, 2, 3, X, Y, Z. So you can follow this one. X, Y, Z, X, Y. X, that's right, okay? That's right, okay? X, Y. And also, when you define the moment, when this is positive, you should also follow the right-hand side, right-hand rule. Bending about this way and then this way. This is the side convention used in the analysis and also the computer program, both, okay? Now, I tell you the local analysis because you can determine the local asset. When you load the local asset, then you load it bending plane. Okay. How to define the local asset? You just obtain, for example, this is the global asset for the whole structure. I want to determine the local asset of the bending of this plane because I want this plane bending about its major asset in vertical plane. Okay. So I need to rotate the global asset until the global asset align with the element. So you can see it this way, and then you should turn this way. I want to do this way. So when I turn this way, then this X asset align with the B direction, okay, the span. So it's depending about this side. Then this should be the major asset. How? Because in the analysis or in the program analysis, mostly will divide the final element according to the axis. This is the x-axis, local x-axis, and then this is the y, and then this is, so bending above major axis should be above z axis. So if I turn this way, then okay, it's bending above major axis. The bit is bending above major axis. Because the element, final element, is always defined according to this side convention. Alright? Okay? So bending above Z is the bending above major axis. You will find it in your output file later. Now you can check. I say I have a formal approach and then I have an easy approach. When the easy approach to check the local axis is like that. This is so easy, this is so good. Okay. When I turn go to the wheel and then this icon. So you can check. Okay, is it about all is about their major axis. All the bit is about their major axis. Okay, it's done. You can check by rotating the global axis collide with the local axis, or you can use this function. That's so simple. Okay. Now, so far you finish the geometry. Okay. Anyone complete their geometry? Can I check your progress? Yeah. Okay. Oh, okay. Okay. You want all this look? Yeah. And then when you want to add when you divide the model, you will do yeah. And then you go high. You want to add the member in between? Okay, so first you need to select the because any node. You need to tell the computer I need to transfer the bin, the signal bin to the main bin through the loop. So you need to add a loop here. So when you want to add a loop, select all this, and then go to the device and you go to the computer and speak. And then you get okay. Okay. Are you okay? Yeah, done. Yeah. Are you okay? Okay. Okay. So first, you know that we have each story, and then each story has the 3.5 meters. And then however, it's up to you. Which one is the bay one and the bay two? But I use this is one bay. Okay. One. And then the two, yeah. Okay. And then for the one, yeah, is 7. And then this is yeah. And the baby is this is the baby. And then for the y-axis, this is the baby. So baby from the y in the axis it should be 7. And then the 6, so you need to move it to 2 meters, then it becomes 8 meters. So you actually you're done. And then yeah, you're okay. First. Not yet done. Yeah, you need to choose all these members. This member, because you know that this is 3 stories, then this is the 2 stories. You need to choose this one, and then And also, this is 6 meter would be okay, but this is 8 meter. You need to move all the look this way by 2 meter. So you need to choose a look like this. When you choose a look, so you need to choose all the look. And then all the figure that you can see in the 3D view. When you pick one, you pick to one member. So that's it. But you know that this is an overlapping one. When you move, you want to, because you want to move this way, so you choose this way by 2 meters. Yeah, they be negative. Yeah. So okay, then okay. You can check. Highlight this one, and then okay, and then the next time we need to split this member into 2, and then add the member. Okay, so anyone you can you done the geometry. When you finish the geometry, we go to the next step because we have the 5 requirements. Geometry is the first one. Okay. Okay. Now you just set up the dimension by using the geometry, the connectivity between the loop and the element. Next, you need to define the dimensions or each coefficient. How? So that's it. You need to define you need to assign material property and then the section property. Okay, because you need to define the stiffness matrix of each element, the stiffness coefficient of each element. Okay. So we are going to second and then first requirement for the computer program or for the most of the structural program. Okay, I have the geometry. If I want to do something or new, okay, once I can go to construct because normally I will have the default value. I can revise the default value. So highlight the material, double click. In your left sheet, this is the 460. Okay, and then they are same. Okay, here is the material property. So that's the last step is section property. Okay. Same, we have the default value. How many sections do you think enough for this project? How many? This is a simple structure. How many sections? Yeah, at least two. I need one UB and then I need one UC. I need a column section and then the pin section. Okay. So first, I can use this one, or you can revise. When you want to revise this, then you can double click. And then import from the database. UK or you have a different country. Australia, China, Europe. Okay, I just live here. UK, and this is the first. This is UB. I want to have a deeper section. I choose a perhaps. First, for the UB, the first number means the depth of the section, and then the second number is the width of the beam. The last number is the density or is the weight. So if you want to save the material, then probably you can choose the number of the section is smaller. Okay. So in here, according to the same depth, I choose 101 is the smaller density or smaller weight. Okay, to save material. Okay. Okay, I choose this one. Okay, done. And also I need the UC section because that's none for you, and then you can go to the construct and then frame section import from the database and choose the type of the section from the IZ and H section, and then the top is UB and the UC is at the bottom. So you roll down to the bottom and then you can try, because I use the UB is quite heavy, 60, so I should use, it means it should carry much load. I should use this way, okay? Now, for the UC, you can see the difference. The first number for the UC section, the first number is similar to the second number. It means the section is quite square. So UB section look like this. UC section look like this. Okay. UB section take the moment by the depth. UC section take the moment by the material. Thicker material, very thick. Okay. Yeah. Okay, I choose this one, and then okay, and use that one. Okay. Actually, you can also define the beam in the transverse direction different from this direction. Okay, up to you. But anyway, you need to add one more section for the brace. You have the brace at the side. Okay. Okay, I need to add one more section. Okay, for the brace. For the brace in the steel frame, same. It should be angle section. Okay. Most likely the angle section. I just try. And change the color because it helps me to read the figure, right? Okay. Done. Because yeah, you have the now you have the brace. You need to add the brace. You add the secondary brace. You need to add the brace. Same. You can add the brace here and choose. Because you know the end connection of the brace should be both pin. So you need to select the top option, the both pin. Okay, so I just keep this one, this loop, and this loop, and this loop, and this loop, and do again for another side. Oh, it's done. This should not have any bracing in the middle. Okay, you can add the brace at this side. Okay, up to you. But there's no any brace here because the obstruction. Okay, that's obstacle for the occupants. Okay. Now we can add the yeah. Go to this way. Yeah. This. And then you choose the section. And then we can continue up. Okay. You did a material property, section property. Okay. Now, is that enough? You need to fulfill the 4 requirements. So far, you define the global stiffness, but the global stiffness alone is not enough to solve this problem or this structure. You need to set up the equilibrium equation. Okay. This is unknown. The displacement based on the stiffness method, this is unknown. We know this one. So that's you need to input the loading, and so that you can set up the equilibrium equation, the loading. So this is the loading input, load input, okay? Load input. Do you remember? According to the unit, you know this is 7 meters and then this is 8 meters. This is the U line. First, you can input the loading on each beam, according to this pattern. but this is I think it's a bit tedious. Second approach is easy. Second approach, I model a virtual slab, a panel element. The panel element can help to distribute the form pressure to the bin by the computer program. Okay. So now you need to input the virtual slab. Okay. When you want to add the virtual slab, it's safe to add a bin element. You can go to the last at your left hand side. Okay. Because I don't need to put any sticklet. This element haven't any sticklet. It just help us to transfer the loading from the slab to the bin. So this is not. We don't need to define any material property for this. Okay. So. Okay, done. And then second. Okay, I want to teach you one more computer skill, modeling skill. You know, I have the step at the ground floor, but this step is same for this one, same for that. Copy and paste is very useful computer skill, computer modeling skill, especially for your model, the large scale structure. Okay, how to use a copy and paste? Copy. So highlight the structure, highlight the element you want to copy, and then copy. Okay. So and then so because you want to copy the step at the first floor to the ground floor, so you want to move this, copy this page downward. So you should put this is the increment in the vertical direction, downward. So this should be okay, minus 330, and then I just have one increment. I just want to copy one time. So this is one. Okay, one downward minus 330, but only 3.5. Okay, it's done. I want to remind you, copy and paste is very powerful. Very powerful modeling skill to help you to smooth your modeling. But also, when you use a copy and paste or revise your modeling many times, you need to merge the load. Okay. Especially when you copy and paste. Because when I copy a member to another member, when they cannot coincident together, I will have an additional load without any attachment. So that's why I need to merge. When this load very close together, they will merge, become one, two become one. Okay. Especially when you copy and paste. But this is very powerful. Normally, you must use it in your future career. Okay. But when you use a copy and paste, you need to sometimes this is a practice for you. Merge. Or I can select all and merge it. That's it. And then okay. There's no any separate load. Because once you have the separate load, you have the mechanism. You can't execute your model. Okay. Now it's done. Now, load input. When you have it, you need to construct or you can modify. Okay, according to your project, how many load case I need to set up the load case? The number of the load case depends on the type of the loading. How many types of the loading used in this project? So I have the 1, 2, 3. I have the 3, and then the cell weight is included in the program. So you don't need to consider the cell weight of the member itself. Okay. Okay, so I had three. There are some defined. Should I use this one or either? You have two different ways. One, you can revise the locate provided, or you can go to the constructor and then go to the locate. Then you have the new locate. Okay, I do one revise it, and then I do one new for you. Okay, for example, I duplicate this here. Okay. Okay. I can revise it, and then I will do it the new for you. Okay. The first one, I had the 4 weights. I have live load. I have finish. Okay. 4 weights is the dead load. Okay. Don't forget to define the dead load. Okay. This helps you to assemble the load combination. Because, for example, 4 weights, you have no idea this is live load or dead load. So, but in your load combination, this symbol will be displaced, and you are going to this symbol to assemble your load combination. Okay, so you should choose the load type according to the loading. Okay, so this is 4 weights, and 4 weights is classified as the dead load. Okay, dead load. Alright, it's okay. And then, okay, I don't use this one. I will create a new one. I will do the finish. Okay, finish. And also, you should leave this factor as 1. You should apply the load factor at the later stage when you assemble the load combination. Okay, this is 1. Finish, and then this finish is the dead load. Dead load. Okay, done. All right. You still have one live load. I will do this way. Go to the construct, pull down menu, and then locate, and then the name is the live load. Because this live load, I change the type. This is a bit this way. The first one is the cell weight. It's automatically considered by the program. You can use this way. You can use the live load cell weight, or you can disable this. When you want to disable this, you can highlight the cell weight and choose false. Then you will turn the yellow side into the right side. There's no cell weight considered. Okay. It means that sometimes you input the cell weight from the 4 step, for example. Then you don't need to double count the cell weight. But now I haven't. So I need to put it yes, sure. When this is yellow side, then you consider the cell weight. Okay. Alright. Now, according to your left sheet, the width, the live load of the width is a 3 kPa. Highlight the element, and then you construct it, so you assign. And choose what you want to input. Is it 4 weight? 4 weight is the 2 kPa. Okay. You know the global acid is not this one. Global acid. So the vertical acid is the set. But this is upward. So you should put the -2 is downward. Also, you have a different option here in this box. Distribute and then project from the global acid. This is referred to global acid, and then this is referred to the global acid. If I have an encounter member, the loading is like the way that, then this is projected. If the loading in this way, then this is distributed. Okay? So this is the difference between project and the distribute. If the loading, you can define this loading is according to the local acid. Okay? Then you may change. You may change. This should be different. When you choose the local, then this may not be this may be Y. Okay. according to the local asset. But now I will according to the local asset to be set. Okay, so downward, -2. And then they are saying, because this is in the orthogonal direction, this is same, projected is same as the distributor. Okay, no, doesn't matter. I choose the distributor. Now this has the two member load or local load. Because do you remember? You add the slab element because you want to distribute the forward pressure into the beam by using this net element. So it should be distributed to the beam and then to the load. If you choose the local load, then all the loading will directly go to the load. Then you haven't designed, you haven't checked the beam. Okay? So in this case, you should choose the member load. And then finally, we have two options. One is the add or the other replace. If I have the O value, yeah, having the O value. So like this, they are same. But if I have the O value, when I choose the add, I will add it up. When I want to revise it, I should replace. Replace is to revise the old value and then put the new value to the low case. Okay, so you should remember, because sometimes you will add more load when you just choose the add. Okay, you add more load to the structure. Okay, I choose that they are same. First, done. When it's done, then you can see this for load is very active. I also want to add the floor load on the first and then the ground floor. Okay, same aside. Floor load and then floor load on the first and then this is a feed. Same. Okay. And then do the finish. Or the okay. I like to choose the finish. Finish is this they are all same. They're all same. Okay, then I would like to choose all and then finish. And then okay, finally the live load. Live load on the roof is 5. Live load. And then live load is 3. Okay, it's done. Then I want to check my load input. I can go to the view pull down menu and then here. 4 load, 3 and 2, yes. And then finish 0.5, yes. And you can see the direction is downward, yes. Live load 5 and then 3, yes. When you keep all the box, they will sum up together. So I just prefer you check it one by one. Okay. Cell weight, you can't see the cell weight, but okay. Nah. All right, it's done. The loading is done. Okay, what's the program? Are you okay? Okay, no problem. But once you haven't input all the load into the structure or in the model, you can do it at home. Okay? Now, anyway, you know how to input the loading. Through the slab will distribute the load to the beam member. Okay. Now, have any loading input? Oh, okay. All right. So, what is the tip? Okay. Let's see. Let's check the loading. Any loading? Okay. So first, you should select the animal and then go to the outside. Because you need to control the loading here. Go to the outside and it's the first. Okay. So is it me? Okay, finish. You can see. So you can do it one by one. Okay, okay, yeah. So because you can do add or repay. When you repay, then you revise it. So you can see you check, or you can see here on the bill, the bill, okay. And you don't need that because you must not the sale rate of one food account by over. What is it? Sale side. When this is right, you don't consider the sale rate. You don't need the sale rate. Okay, I confused it because okay, but anyway, the relative it should be the 5 and then this is big. The line of this is big and then 5. Okay, doesn't matter. I just showed you the way you model. Okay. Okay, and then follow, okay. Okay. All right. But you cannot the capital. Because you should make it for me, okay, I forget it. Okay, yeah. Yeah. I forget to assign the UC for the column. I forget. Okay, how? Okay, now can you tell me how to assign the column section to the bin, to the column? UC section to the column. First, this is the modeling scale. I have a different approach. So according to what you learned so far here, can you tell me how to assign the column section faster, easier? There's no copy. For this is now. It means that I need to select it. Okay. Now, I have the place. I can choose in this way. When I choose this way, I also highlight the place. So I can make the place disappear. And then I can choose the, okay, this is a modeling scale. Change all the vertical element and then change this in, okay. And then finally, I just Okay, they come back. Okay. Okay. Now, so far. Okay, because you can go to this highlight this highlight the bridge, and you highlight the bridge, then you can see they are all selected. And you can hide the bridge, then you can see okay, so yeah, because the following procedure is typical. Okay. So far, we have the loading. Loading done. Okay. Done. Because okay, I think that there's some new modeling skill is to select because you want to hide all the brace member. So once you can select the brace, select the section of the brace, and then go to the hide selection. Then they are disappear, and then finally I can choose all the vertical member. Okay. Or I have another. There's a different method. For example, I can do this way. There's a lot of the modeling approach. For example, I want to go to the okay, I want to go to the PolyU. And then I want to select. Oh yeah. Another way is very easy. Okay, nah, doesn't matter. When you hide that way, okay. Now, when I hide the bracing, why don't I hide all everything? Okay. Yeah, I think this is a more simple way. Hide the bracing and then select the horizontal. Right? Now, okay. So select again. Okay, all right. Done. The property course can help you to define the detail, section property, material property, or the job collection. Now, you have the loading. Is it enough? We have the last requirement because so far you set up the equilibrium equation, but however, this sticker matrix is not really a structure. It looks like a vehicle because you don't impose any boundary condition. When you have any boundary condition, you can get the inverse of this matrix. This matrix is the linear dependent. Okay, until you can erase the corresponding degree of freedom, such that it will become determinate structure. When you erase more degree of freedom, it means that you can impose more restraint. Then will become from the determinate structure become the indeterminate structure. That depends how many restraint you impose in the structure. But so far, we don't have imposed any boundary condition that this structure, it looks like a vehicle can move. So we should impose the restraint or boundary condition. It means I just erase a number of degree of freedom. I should erase the number of degree of freedom until this structure become from the mechanism to the determinate structure. If I keep impose more restraint, I will turn this determinate structure into the indeterminate structure. Okay? But now, so this is the I need to impose the boundary condition. But now we can go to the home and then make it active. In the template, is it defaulted? The column should be supported by the pin end. Okay, so it means okay, I will impose the boundary condition to this structure. Now is that finished? Quite close, but however, Do you remember? I say the secondary pin connected to the main pin, it should be the pin end. I did the pin end for the brake, but I didn't did the pin end for the secondary pin. Or you can define all the pin in this transverse direction as pin, doesn't matter. But however, for this pin had to be pinned, and I explained that before. Okay. How? This is easy. Highlight the element, go to the property box, and choose all this pin. You can check your model by go to the here, highlight this, so you can see this look turn to the yellow and red. It means that it's the pin at both ends. For you, when you impose the boundary condition, you erase the corresponding degree of freedom. For this measure. When you impose this is the restraint, this is also the restraint. You release the restraint, it means that you impose the condition. For example, this moment is equal to 0. Okay. So this boundary condition is the external redundancy, and that this is related to internal redundancy. Okay. You want to impose more external restraint, and you make it to become indeterminate structure. But when you release it, you turn the internal redundancy into the release the restraint. Okay. So I just want to say this is referred to the degree of freedom. So this is the global external, and then this is the condition between the element. This is the internal. So you will have the internal redundancy and the external redundancy. They are different. Okay. Yeah. We can discuss after the. This is let you know for the structural analysis. All right. Okay. So far we did all 5 requirements. Now, and I say. I didn't do the sample for the no combination. I like to do the no combination. Yeah, you can do it in this way. After this session, but I like to do it in the analysis. Now you go to the analysis. In this project, you should get the loading from the linear analysis, and based on this loading, to design a bit and a member or a connection. Okay, so you should use a linear. After this, I like if you're interested, I can also deliver the how to use the second order or nonlinear analysis. I will do it later after this. Okay. As I told you. I just tell you, for the nonlinear analysis, even the engineer in the big consultant firm, it's very difficult for the engineer to use the nonlinear analysis. Because nonlinear analysis is not that simple, you may experience the divergence. How to solve the divergence? It means that you need to, based on your structural knowledge of the computer theory, or the engineering said, how to stiffen or strengthen the structure. That's not easy. The divergence problem is quite difficult. Yeah, so this is not common, but I can see in your future, the computer program will develop more advanced, and then you need to base on the nonlinear analysis for your design in future. So I will tell you after this later at the end of this computer lab. Okay, first. Based on the linear analysis, you get the loading, and then based on this linear loading for your design. Okay, so I have the default and then duplicate it. I can choose this design or analysis only. It should be at the design. Because when you add the design, it can help you to check the method is this enough to take the loading. Now, this is so simple. I like to assemble the load combination in here. You just need to consider one load combination, one load count. It's a 1.2, 1.6, 1.4 and 1.6, okay? Live dead load is 1.4. Dead load. Live load is 1.6. Okay. And don't forget, you should name the load. Each analysis refers to each load combination because you can check the load distribution from the corresponding analysis or from the corresponding relevant load combination. So you should relate this one, okay? Help you to get the right solution for your design. Okay, done. When it's done, okay, we can check it. Everything turn green, then it's okay. So you can base on this session for your design. Okay. You can see when it is blue and then the red is not okay. When it is green, it's alright. Okay, you can check another way. Go to the utilization. Everything within this side is okay. When you find something in more than one, then that's not okay. Okay? Or because I have many members lie in this range. This is not economical. Or you can put or all the sessions should be around here is better, but up to you. Anyway, okay. Design procedure. I just check your design procedure. But finally, how to read your result. Go to the analysis result. If you have more than one, you have a more than one analysis. I just have one. You have more than one. There have a number of options. And a number of options, and then you can assemble this page. But now I just have one. Okay. Now, tell you. I just have one, so that I don't have any option. This page is what you want to output, what you want to read. So probably I like local displacement. Local displacement. I want to check the serviceability. Okay, but if this is the serviceability state, then you need to check this one. Check reaction. Check envelope. Or perhaps I don't need to check all. I need to check the envelope and the maximum length. Yeah. Or for the reaction, I check. The local displacement you can check it. Yeah. But I forget to tell you. In this computer lab, you are required to calculate the NIDA critical. So that's you need to get the local deflection, local displacement. Okay. How to do that in your yeah, because you need to classify the frame straight or not straight to decide the column. So you need to, this is a rectangular frame. So you need to apply the load force. For example, I have the frame here. When you apply the load force at the top, and then you can read the local displacement and put it in this formula. And then this is the total height. When you put the load at the second floor, then this is the height should be referred to the second floor. And then the lateral displacement should be at this point, at this floor. And then you can calculate the NIDA critical. But anyway, I think because this is a rectangular frame, no matter you base on this floor and this floor, they should be similar. Okay, because it should be proportional. Okay. So this is you read the local displacement because you need to calculate the lateral critical to classify the frame. Okay. But you need to apply the rotational load. When I say okay, yeah, I get the result. Okay. You think it's not detailed, okay, you can refine the option in the page you read before, okay? You can get the loading and then for design. Okay. Alright. That's simple.啱啊 ，OK。咁你係啊，咁係好啊，係啊，OK。哦，你嗰邊你哋嗰個按係咯，呢個高度喎，你有特經呢就特經係啊。呢啲就係類似啦，係咪嘅？依家係打緊落市嘅，但係你有 first 咧，我諗你 complete 咗嘅話，佢應該一彈咗就會出嚟咗，就可以但係你冇彈出嚟。呢樣嘢咧，但係最唔需要呢樣嘢。呢啲咧其實咧係麻煩嘅，但係咧你係可以經啲 experience 啦嚇。全部光係啲啱唔得啊唔得啊！呢度有全部光都係偏咧，所以呢兩條係偏，同埋啲偏係偏。其他咧呢度咧你可以揀咧呢條咁你一第一咧，我覺得你要睇到過去啦。
佢温嗰陣咧，你試彈出嚟，只有分數。我哋自己揾出嚟睇睇，真係
你呢個咧，你睇落去啦，你呢個反應咧，你就冇買。所以呢樣嘢係咁大嘅，係啊。咁你呢個咧，你個擺喎。然後咧，你又呢條佢咧，你。 呢個係偏尾呢兩個，係啊，所以你下呢係啊兩個色啦，呢個未必係色啦，多啲，所以咧你下咧仲有我哋呢個咧，你溫唔啊嘛，係啊，所以呢度咧要銀落去你相對快，咁我哋就下底啲嘢，下底啲同埋你喺個OK 啊，睇睇。OK 啊，睇到嘅。係啊，因為冇人冇嘢嘅喎，你可能呢個 program 有問題嘛，你可能要試下你嗰個。揾唔到喎，但係就應該你試下攞呢個 data file 去第二個computer，可能呢個 computer，或者你用呢個試下嗰個 data file 一樣，但係用第二個 computer。啲裝，OK，我知。哦，唔係，呢人一定要編。你呢個唔編咧，你第時你變翻個裝機啫。係啊，你嘅操作人咧係你唔係呢度㗎，你唔係呢度改㗎。呢個係 internal 㗎，呢個你下呢個碌啊，碌啊唔知下呢個碌啊，下呢個碌咧。所以你其實呢個我哋考慮咧，啲有啲嘅，我下呢就所有。OK， 咁啊，你仲有咩啊？你講晒啦。OK。咁啊，你咧就要 highlight 佢有個有冇加個 set？ 有加 set 㗎？而家冇，即係加個。你改嘛？你一改咧就要係。If you done your analysis, but you want to revise it, for example, I done the analysis, I can't revise my model. I had to go to the home and then unload the result. It means that when I unload the result, I erase all the solution, and then I can change. Okay. So once I unload and clear, and then I can change the property, change the value. So you need to unload first. OK，例如咧，你而家你係改例如你識改到呢個我哋又係配翻個顏色，你一改就係如果因為咧，因為你可以去到一個你可以入喺度入，你呢度入嘅咧就係你可以喺度入，你可以喺度入。你可以喺度入，你喺度入咧，咁你喺度做，咁你點樣就例如咧，例如你咁樣嘅，有個方法嘅。 但係如果我喺度做我之後擺喺度咧，我全部即係1.1點就俾晒嘅。咁我就咧係喺個 analysis 嗰度 present 冇所謂嘅，係咯。同埋你一定要回歸翻咧，你呢個 analysis 咧，因為一定寫一啲落，因為你係時咧就淨係睇個呢個。你會加我嘅，係啊嗱，你例如可以1.1點啦，或者係1.1點6。咁你咧呢度咧，如果你加多個窿粒咧，你一定要喺度加嘅，因為咧呢個 case 咧好難嘅，第時咧你會喺個回收度咧有得俾你揀。咁你擺晒你一齊嘅咧，咁第時咧所有回收咧擺晒你即係呢個 case 係個窿嘅，所以要分開。Okay, so you want to change the balance condition? No. And then you can increase the session. Or because the loading may be wrong. My loading is not same at the lecture. But anyway, when you find it back, you need to increase the session, make it 20 grade. Or you can highlight you can change here. First, you may load. And not there. That's all. You can rewrite it. Here. And then you can revise it. You can change this. Because you want to change the big. Oh, change it. Highlight it. Okay, so you should go to the home and then unlock it. Okay. Yeah, when you want to revive, you go to the home and then okay. Are you okay? Alright. Yeah. Okay. Okay. 不過你呢個咧，你翻去係邊啊？你因為嚟講啦，你想睇個 definition 咧，你就可以去到呢個，因為而家你地方好細，所以你可以加大啲白嘅。咁你就會變啦，或者唔夠大啲。 但係你擺 step 可能你個 moment 係應該有問題嘅，即係如果你調翻到應該有擺 step 嘅，不過呢個 computer OK， 你可試下開用第二個 computer。你唔係你可以20蚊，然後你就不過唔係㗎，因為你又仲有揀過。
你開點開頭嘅，咁你應該係咪啊？好入道，係啊，即係
你可以試下嗰啲嘢真係試下再溫過。如果唔係咧，我覺得咧，你試下咧，仲第二個同機好怪嘅，好怪，我都唔知㗎。因為你調翻到嘅冇幾久嘛，你調翻多啲嘅佢會好多個 special。但係如果我哋交嗰間嘢，唔係交唔多用。即係你睇下你 design 咯，嗱 design 個 member 有少少係你要 member force 嘅，咁啊你個 information 嘅計嗰個即係我覺得 OK 咯。你唔高咩我再加啲。Oh, okay. Now, so far, have you complete your model? And then you also get the loading. Yes. And then every member return green. Green is not bad. Or it's not blue. Then you can get the result from the exam. And then you can decide. So now you complete the model. And then you can model the design procedure. Based on the loading from this model. And do the design calculation. Yeah, you can do the go to the next step. Do your report. Oh, 你睇你做嘛？咁你就攞住去到嗰個即係你做，係啦，你就可以有。我可以俾你玩嘢。啊，你可以你轉咗邊啊？咁我 check 下係咪先？去到呢個你下咧呢個你就見到變曬啦，變曬呢度未變。呢個 base 一定要編，係啊，3個 base 要編。OK。你生入邊？係啊，你而家就睇好翻你個。你而家咧，你度咧揾翻個 logo， 喺嗰啲寫法，或者你其實咧，你呢個咧，你呢個咧，佢都會 double key 呢個咧，佢都會有寫嘅。不過如果你嗱，即係 Excel 法咧，係 good for 要用緊即係呢個 combination， 你又見我話跟住 combination 嘅生佢都好多，所以講話係同你嘅我咧係新呢個時候咧，你有咁樣都得㗎。Anyway, I want to tell you, you have the two ways to get the loading for this You will want to check the loading. You just double click the member you want to check. So you have the all the random moment and then the CR4. That's enough because you just have one low case. If you have many low case, then I prefer you use the Excel. Okay. Now, finally. And I say, so how to use the second order or linear analysis? Now, this is a linear analysis. Linear analysis is just for you to get the loading and then design based on the linear loading distribution. But now, second order analysis can help you to design the buckling effect or geometric nonlinear effect. You don't need any calculation for the buckling effect. Okay, so this is very convenient when you load. Okay, I want to design by the second order analysis or nonlinear analysis, and then I should go to your app and then nonlinear. Okay. For the nonlinear analysis, there are a number of the parameters. So that's it. I want to illustrate what are they. If you base on the nonlinear analysis, sometimes you may encounter the divergence problem. Okay, so that's it. You need to understand what is this parameter. Okay, first you have the load cycle. Okay, you load that. This is the load diffraction curve. When this is the real structure, most likely will critical to the nonlinear effect, no matter this is a material nonlinear effect or geometric nonlinear effect. Okay, so it makes this load diffraction curve look like that. So it's not a linear. If this actual behavior is a linear, then I can use a linear analysis because linear analysis look like this, but this is not the real structure. Real structure should be the equilibrium part. It should be the nonlinear. Okay, look like that. Now we need the some iteration or the incremental or the numerical procedure. Numerical procedure look like that to trace the nonlinear equilibrium part. Okay. You know, for our design purpose, this is our design low level. For example, in this analysis, I took 1.6, 1.4, 1.6. I want to check the loading distribution at this point. But however, this equilibrium part is nonlinear. How to go there? So, because this is nonlinear, I may not can reach to this point by one go, by one time. I need to divide this load by perhaps 1, 2, 3, 4 by 5 times. Okay, by 5 times. 5 times. Yeah, this is a highly nonlinear. One load step is not enough. Maybe 4, maybe 5, maybe 10. It depends on the nonlinear effect. Okay. So perhaps I think I need 5 load steps to reach the total load level. Okay, so I choose 5 load steps. When you enable this term, it means that the design load level is a 1. Is a 1. So I have corresponding incremental factor too. So you can say if I increment 0.2 by 5 times, it can reach the total load level at 1. When I add 5 times, then this is 1. Okay? So this is what the low cycle means. Okay? How many cycles you want to break it down such that you can reach the equilibrium point by point easily. Otherwise, you will diverge somewhere. Okay? Now, second, because I say this is the analysis is the numerical procedure. You need to try and error at each low cycle. So this is the iteration. So if this is the problem is very highly nonlinear, so you will need to increase the number of the iterations. One iteration may not enough. You can increase the over 1,000. Okay, that depends. Is it highly nonlinear? Okay. Now, finally, you have three options here. Newton method, or this load is a variable load method. This is a constant load method. Okay. What is a constant load method? Because constant load method is to increment the load cycle constantly by 0.2, 0.2. But however, when you use the arc length or the displacement control, this is variable load method. For example, the arc length. The arc length you cannot have 3 low cycle, you need to define the first one. Because, but however, the Newton-Raphson method is good for your design because it can guarantee to reach your design low level. One by one to reach your design low level, this is equal to 1. But however, the constant load method cannot predict, cannot trace the nonlinear equilibrium part when it's subjected to the shortening effect. Okay? Because it can only predict increase, the signal increase, no shortening. But however, when you base on the variable load method, this is arc length. This is the iteration scheme. When the iteration scheme follows the arc length, then let's go like this. So you can trace the equilibrium when you're falling down at the softening behavior. So this, the Newton method is good for your design purpose. And then the other method or the displacement control is just for you want to understand the behavior of the structure. If there's no any shortening effect, supposedly the Adler method and then the Newton method can yield the same equilibrium part or the equilibrium solution part. Okay, but anyway, I can say anyway, the Adler method or variable load method cannot guarantee to reach this point. May stop somewhere, may go somewhere very far. Cannot get the solution at this point particularly. Okay? So you want to design at the particular point or particular design load level, you should base on the Newton method. So I say that okay, and also here in position, when you based on the linear analysis, you need to apply the notional load and get the deflection. Based on the deflection, you can calculate the lambda critical. Okay, but now when you use the nonlinear analysis, okay, go to the imperfection. Actually, notional load is the virtual load you load up. The limit is this doesn't happen. But you need to trigger the P big delta effect. You need to make this member incant a little bit, tilt a little bit, and then to simulate the P big delta effect. Okay, this is the purpose of the notional load. Actually, the imperfection can do the same way. Because I impose not the loading to the structure, to this model, I impose the displacement a little bit offset or original asset, such that it can bend like this. This is the P big delta effect. So you don't need to, when you use the nonlinear analysis, you don't need any notional load applied to the model. You just need to activate the initial imperfection. The program can help you to calculate the P big delta effect. Once it can help you to calculate the P big delta effect, it means that it helps you to design the strain, the buckling due to the strain effect. Okay, so you don't need the calculate or have any design procedure related to the buckling effect. Okay, but however, because this is a second order analysis, finally you also need this capacity factor. Because this program can effectively account for the second order effect or the geometric nonlinear effect. So you don't need to get the PC because you calculate that from the program. But however, you need to get check this. This is the section capacity factor because this program hasn't included the plastic behavior. So you also need to check the section capacity. So it means that because the linear analysis haven't helped you to check any geometric nonlinear effect or material nonlinear effect, so that's it. You need to check this by yourself. So this is why you need the hand calculation. But however, when you based on the second order analysis, or even this is the second order analysis and elastic analysis, you don't need any design formula, or should we get it from the numeric, or can get it numerically, solve it from the program. Okay, so same, for example here, this is the dead load, and then live load. Okay, done. And then I run all this. Yeah. Then you don't need to check the buckling load of the column due to the PP delta and the small delta effect. It calculated by the computer program. So this is when you can use the nonlinear analysis, it can help to proceed your design procedure quicker, faster. You don't need any calculation. Okay. So that's done. But anyway, according to this project, you need to base on the linear analysis and then based on the linear local distribution and check and do your calculation. Yeah. Just because linear analysis cannot consider the nonlinear effect, you need to design formula. You need design formula to help you to make sure it's safe. Otherwise, you just rely on the computer program. But when you want to rely on the nonlinear program, sometimes you will encounter the divergence problem. For the divergence problem, this sometimes is difficult to solve. Okay. Yeah, so they have a good thing and a bad thing. Okay, finally, I also want, because I just mentioned in my tutorial class, I can do the revision. I can do the revision at the week you have the midterm test. Because I think this can help you to prepare your midterm test and also your final exam. In this revision week, maybe next week or week 11, I'm not sure. Just depends on when is your midterm test, okay? In this week, in this tutorial class, I will demonstrate how to prepare the question, and then what you should focus for this question, and then finally, how it can get marked, and then you can pay attention which procedure you may get the mark. But however, because this is my own personal information, I won't circulate online. I would like to put all my question, all the solution, and then the marking scheme, my own marking scheme, on the whiteboard. For the online student, they can read through the webcam, but this is not here. So I just highly recommend you can take my tutorial class in person. Okay, on the week you have the midterm test. This is not, you know how to prepare the question. Then this is not for your midterm test. It's also for your final exam, because the final exam is quite consistent with the midterm test. Okay, I will tell you how you read the question, what you should prepare for that. And then according to my experience, the student can. This is my experience last year. Many students can get the good grade, the A grade in skill design. I hope you can do the same thing. Okay. All right. Any question? I think you all complete now. And I just invite you to come back to the computer class and then do that on campus. So now you all complete the modeling. Your computer model is done. That's so simple. You may revise or refine a little bit at home, but anyway, you did it. And then the next step is to prepare the report, do the hand calculation, and then prepare your report. It's done. Okay. Any question? You done? Yeah.你有睇過，你有睇 information 㗎啦，你有晒 loading 㗎啦。用呢度嘅 loading 咧，計翻你計呢條 column 或者呢個 column。然後你又計翻個open collection。open collection 係我諗咧，你就 after 講咗個點嘅 design 啦。而家你 design 唔到啦，你就做咗條 B 同埋 column。Anyway, when you want to, I think you can do it as soon as possible, because the hand calculation for the B design and column design will also help you prepare for the midterm test, because this is all the calculation. So I think you should do it as fast as possible, because when you have time, you should prepare for your final exam, not for your computer lab. Okay? Alright, so you know what I mean. Do it as soon as possible. You design the page, and then you can design the column based on then the other student is design the column. So each student is design one man one collection. You can't design the main collection. One collection is the base one. The other is the column. Big column is that's not big. Big column collection is okay. This bin or this bin, this region, this bin can transfer over to this one. This one is the movement.
你有冇上十張樣嘢？我咁樣諗法，我4至10，即係睇翻我4至10。但係見唔到我對客唔一樣。
Collection design is quite different. And then I'm going to learn this here. The very collection, so many students not the mark in the extension because of their collection. So no hurry. After the oh, because when you're very hard behind your linear, you cannot switch from the original form to that form. So that's this is very important. However, when you're high linear, one you need to break it down so that I can reach form by form. When you not go ahead, you are divide the total load divide it. Yeah, because when I have 100, I want to make five times go to 100. So each time I have 20. So to make 20 is easier to reach more than 100. Because 20 may not have a very good value. But however, when I apply the 100, it may buckle and make my distribution difficult. Yeah, big down the total load set to define. So it's easy. First of all, no. You have to make it under 10 or 4. Or you need to take more time, but however, easier to reach the final goal. Depend on the height of linear.
你邊度啊
4至10係
？4至10同你4至10可能唔一樣。
一樣，啱啱要 check 佢。
Yeah, this is
4至10係呢個。
Okay, you can go.
呢度係可能一定要。
And then go to the file.
唔係你兩個魚腸一樣咯，啱啱即係一樣㗎嘛。我個數白帶。
Okay. 呢度咧就係咧 one member design collection design 咧，你未知嘅，你再諗下啦。不過你而家可能會係長嘅 design 因為其實都聽唔聽你 design 曬嗰啲嘢嘅。咁咧你有 loading， 咁咧你咧如果你講咁咧你就非常之做啲你有晒㗎啦，喺你有晒嘅情況下邊，你就非常要咁嘅 loading 咧，你自己我唔再翻成咁所以講過咧，你要用如果你 design 個可能咧，你就要做呢個 step 啦，你要計到個簡直你放條邊咧，你就要計嗰個。所以而家
邊個撈嘛？
你咪照住嗰個好細㗎，你只不過咧嗰啲人生活出嚟咧，一次。OK。你試下用第二個嗱，因為有個問題咧，佢呢個全部咧都係automatic同你 highlight 曬佢。我就你所以你試下換一換個computer。我識到啦。OK。3換啊嘛。係啊，
我嘅答案我
哦，咁啊，我諗用翻隻啦。我都唔都係講嘅呢個。一，
我哋做啲嘢，我開始一樣難處理。
嗱，你一咧，你班啲 condition 咧，係咪就即係呢啲人多？但係你可以去咧，又可以去咧，應該咧都唔會點大嘅，係爭幾遠啊？
即係攞啲嘢。
係啊，係啊。我爭100喎，爭100都唔係你就係你如果咧，你係咧都係入面計嘅6.4啊、6.7、6.8都 OK 嘅，10% OK 嘅。你大佬呢個係咪好大嘅？即係600幾啊嘛，600幾啊，600幾爭100喎，5%成都好大喎。如果你呢個好細個 manage 好細咧，有啲唔係 OK 嘅。係啊，呢個 P 啊，你爭幾多？你要 check 翻咧。anyway， 有少少啲份咧都 OK 嘅，你最緊要咧，你都係 check 翻你嘅第三條資料嘅啫。你邊上8又好，佢邊上700咧，我哋邊係啊，你計邊咧就計我 A 嘅，一定要計呢啲嘅。因為A 咧係多啲圖書係你啲咁嘅但如果你係二三科咧，就 S E F 咁理解，冇得做嘅。咁咧就係如果一個學生咧，就係一條 handbook design，一條 collection design。collection design 咧就 collection 或者係做工作。但係 anyway 嘅高學生咧，你哋都未知㗎，你唔需要做字㗎，因為你唔知點做。所以咧而家有時間咧快脆咧做個因為咧咁睇 test 咧都係考handbook design。而家你做咗咧，咁你咪可以歪晒咯。而且你又可以 save 啲 time， 後咧你可以啲人你個交落聲。你一係咧你可以用寫法，唔係咧嗱，因為你而家得一個機嘅，你 demo 時咧你亦都可以咧得到呢個。你呢個唔係你屋嘅，哦，你溫咗？你個有冇溫咗？你溫咗啦。嗱，一係咧你可以用個 Excel file， 唔係咧你亦都可以咧就係 double click 佢 ，double click 個 member， 你就淨係縮，因為你一個 OK 啫嘛，你咪淨係縮一個嘅 band moment 咁咪做咯。因為你一個 OK， 頭先你 Excel 咧係放你 practical work 嘅。有好多個 location， 咁你有成個 file 啦，唔係啊，你淨係 output 一個 location， 你咪用呢個嚟睇翻你 moment 啊、SO course 啊，咁搞掂㗎啦。OK。哦，係呢樣 OK 啊。旁邊就你唔使嘅，即係你用翻唔用啦啲人，我即係 information。connection 位係要手動調嘅，但係呢個唔用。係我數冇錯，就呢個爆炸。都唔知嘢嚟嘅。咩啊？錯咗啊！刪啊嘛。冇啊！呢啲就係手動轉嘅，唔係呢個自動。呢個自動咩有個關於其他嘅嘢。佢全部 K 2嚟嘅，咁撳。我有 value 㗎，真係嘅。嗱，我哋一樣。哦，你後邊嗰度有上嚟㗎嘛？未安係啊，佢有個line。係啊，自動機啦。你唔使 睇過你唔使睇過醫生咩？你自己試用啊嘛，你識用你咗啦嘛，所以我覺得你少睇㗎。我你唔記得咗嘅，咁你就其實你可以睇嘅，但係我覺得咧你就唔好，你就唔好因為好真係好呢個你用咩時間咩啊？嗱，你呢個其實咧其實好㗎，好咩嘢嘅就係呢啲 acid 啊，你就唔關事啦。冇嘅咧，你就要狂濕佢啦。你狂濕咗啲嘢咧，你要壓曬㗎嘛。咁你呢個即係壓曬佢咧，就真係咧，我有一樣嘢俾落條邊度，或者俾落條哥諗度咁樣嘅咋。係啊，所以咧，你咧就知道啦。呢啲咧事咧又係即係每一個負擔 manual 咧係一個 action 嚟㗎。係啊，咁你知道就係個 action，咁你去到個定嘅負擔 manual 咧，咁你就揾翻啲都唔㗎啦。你部邊度嗰個而家係咧，呢個咧就唔係 NIDA 嚟嘅，其他 any 都係咁你其實你都搞掂㗎啦。咁你嘅最後呢個咧就係 analysis 咯。你做 analysis 咁你就咁個搞掂。係啊，即係但聽日唔係 revision 嚟㗎，係啊，聽日係係一樣㗎，係啊，今日講嘅啫，同聽日講一樣。revision 我唔知幾時，我真係下個禮拜或者再下個禮拜，因為我invite你即係所有同學咧，都最好就因為聽日會11點半。OK，阿生到啦。